This is lesson number 56 in Algebra 1, Finite and Infinite Sets, Membership in a Set, and Rearranging before Graphing. Alright, you've got two words here. One is finite and one is infinite. Finite means that it goes on forever and ever and ever. It has no bound. It is unlimited. It's something that we can't understand in our little pea brains. God is infinite. He is without end. There is no beginning. There is no end. Same with time. Same with how big numbers get or how small numbers get. They just go on and on and on forever. And the symbol for infinite is kind of like a sideways 8. It looks like that. Now again, if you continue in your math career, you will use that symbol. You will use infinity all the way up past calculus. I mean, I had it in advanced calculus, so as far into math as you can possibly get, you're going to use that infinite. So having an understanding that it is without limit. Finite, on the other hand, means that it does have limits. It is bound. It's something you can think about. If I've got a set of 4 numbers, it has a finite group of numbers. There are 4 numbers. That's a finite number. You can count that many. So a set with finite numbers is called a finite set, and a set with infinite numbers is called an infinite set. If I had a set like this, 1, 2, 3, 4, that's a finite set because I have a finite or a countable group of numbers. If I had 1, 2, 3, 4, dot, dot, dot. That dot, dot, dot means that it goes on forever. It continues following this pattern of 1, 2, 3, 4 forever. If I had a set that looked like this, dot, 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 again, that would be an infinite set. And what happens here is I look and see what kind of arrangement or what kind of sequence my numbers are going, and it's even numbers, so that means it goes on forever using this same pattern of even numbers. So that's a infinite set. And what we do when we talk about sets is we give them names. We give them names with capital letters. So I might want to call this set B. So set B contains the numbers 1, 2, 3, and 4. Maybe I say set C contains this one. So let's just get rid of our infinite here and go to finite. Set C contains the numbers 2, 4, 6, and 8. And we can designate our numbers like that, but one of the things that's important when they give you a big list of numbers is you only show repeating numbers one time. So if I had the numbers 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, sorry I didn't put commas after all those, and I wanted to tell what that set is, it's the set 0, 1, 2. Okay? Even though it has a whole bunch of numbers, we only list the number one time. Okay? The order in which the numbers are listed are unimportant. They don't have to be numerical from 0 up. But what we have then is we would say that each one of these numbers is called an element. Okay, each one of those is an element. So 0 is an element of set A. 1 is an element of set A. 4 is not an element of set A. And we have some symbols that we use in math to describe that. So I would write 0. The symbol for element is kind of like an E. 0 is an element of set A. I could also write 6 is not an element of set A. Okay, so just some little symbols there to help you understand what you've got there. Alright, so let's look at an example here. And that's pretty much what this lesson is going through, is just some new material here. It might not be new to you. Maybe you've had this before. I hope you've had it before. 0, 1, 3, 5. And let's say we have set B. And set B has 0, 4, 6, and 7 in it. And set C has the elements 1, 2, 3, 5, and 7 in it. All right. So, is 5 an element of A? Is that a true statement? Yes, it is. Is 4 an element of set C? No, it's not. Could I say that 5 is not an element of B? Yes, I can. Because 5 is not in there, so if I say 5 is not in there, then that's a true statement. Okay, let's go to the next example here. Alright, this is example 56.4. Let's see if these are true. Is 6 an element of L? No. Is 0 an element of N? Yes. Okay, so that's it. Alright, let's go and look at rearranging before graphing. What we're going to do in this section of lesson 56 is we're just going to rearrange our equations. So if I have something like this, let's say that I don't want it written that way. Let's say I want the variable by itself on the left side of the equal sign, so either the x or the y. Alright, so you will give a graph, or you will give an equation like that, and they'll say graph that equation. Well, one of the simplest ways to graph that equation is to get the y isolated, the y by itself on the left hand side. So we're going to do that first before we graph. Okay, so for example, if I wanted to graph without doing that, you remember making these tables? Now let's say I make x 0. So I have 3 times 0 plus 2y equals 4. So this is going to be 0 plus 2y equals 4. Divide by 2, divide by 2, y equals 2. So I can put a 2 there. Okay. Let's say, for instance, I want my x to be negative 2. So I'm going to put a negative 2 in here. Remember, you substitute so you can find out what value works for y. So negative 6 plus 2y equals 4. Add 6 to each side. 2y equals 10. Divide by 2. Divide by 2. Y equals 5. Okay. So you can find the points in order to graph this, doing just what I did here. But I'm going to show you another way to do this. And some folks think it's easier. Some folks think it's harder. But regardless, we need to learn how to do this. So in this particular one, we're going to solve for y first. We're not going to plug any numbers in. We're just going to get y by itself on the left side of the equal sign. We're going to start by subtracting numbers added or subtracted to that y. So that goes away. I can't do anything with the 4 and the 3x. I can just stick them together because I can't add a variable and a number together. Now I divide by 2. Remember, when you divide one side, you divide the entire side by 2. So now I get y equals, and then I can split them up. Negative 3 plus 4 over 2 is 2. So now I just changed my equation around. I didn't solve it, but I changed it around. So now when I have an x and a y, I can put a 0 in for my x, and this becomes negative 3 halves times 0 plus 2. So those go away, and I just get 2 for my y. If I put a 4 in for my x, so again, you're still using the table. Okay, so negative 12 halves plus 2, so negative 6 plus 2 is negative 4 when we put 4 in for our x value. And then you can just start plugging numbers in for x here to find your y so that you can eventually graph. Now remember, when you graph, you only need 3 points. Alright, so let's find another one. Let's use a negative 4 for my x. So y equals negative 3 times negative 4 is positive 12. So this will be 6 plus 2, which equals 8. So when my y is x is negative 4, my y is 8. Alright, so now that I've got all of that stuff there, or I've got my 3 points there, then I can go ahead and graph this. So if I've got my graph, and 1, 2, 3, 4, 5, 6, 7, 8. Isn't it fun to sit here and watch me make this graph? Alright, so I'm going to graph 0, 2, 4, negative 4, and negative 4, 8. I draw my line, and you have to get a straight line. So you put 3 points in there and you connect the dots, you better get a straight line or you did something wrong. So that's pretty much it as far as that. Let's do one more, and we'll call it good then as far as practicing this. So if I have y minus x equals 0, I want to solve for y. So I'm going to add x to both sides. So y equals, because those go away, 0 plus x, or just x. Alright, so now I'm going to make my little table. When x is 3, what's y? Well, if x is equal to y, if x is 3, y is 3. If x is 0, y is 0. If x is negative 2, y is negative 2. And when I graph these, what I get (3, 3), negative 2, negative 2. I get a line basically that cuts right through the origin that looks like that. Alright, so that's it as far as graphing these. This shouldn't be too terribly difficult because it is a combination of a bunch of stuff that we've been doing in the past that we just kind of put it all together. So shouldn't be too bad for you to go ahead and do that. So that's it for lesson number 56.